Hey everyone, good afternoon and welcome to our live streaming this Friday for our preview of the daily ACT questions from this past week. This week has been completely focused on science, and we have here a passage with two charts, two graphs, if you will, that we are using to answer these two questions. So if you have been preparing for the ACT, particularly the science section, then you know that the majority of the questions are based on analyzing data, okay? And so these sample questions right here that I'm gonna go over that are actual released official ACT test questions, they are no different. They are based on the data. Okay, so we are going to just jump right in here, taking a look at question 21. And guys, while I go over this, I am going to actually work them out the way I would if I was taking the test. And that means I'm going to be implementing strategy. And I'm telling you that because I'm going to go directly to the question. All right, so when you hear the directions being read to you on test day, it's going to say, read the passage and answer the questions and select the best answer. But I am telling you, disregard what you hear the test monitor say. And when you're working on these science questions, you're going to go direct to the question because the majority of the time, the question will direct you to where you need to be. Most of the time. Okay, so since that is the case, since we know that question is going to tell us where to go and get the answer, then we're not going to waste time reading the directions or reading the passages before checking the questions. We check the questions first, and then we'll decide if we need to read based on what we see in the question. So with that being said, let's dive into the question from this past Monday, which is number 21. It says, according to figure 2, the maximum positive value of V sub S, and I'm sure they tell you what that represents in the reading, but right now all we need to know is that symbol or that abbreviation. V sub S was approximately what? So we have A, 125, V, I'm going to assume that's volts, but like I said, I haven't read the passage yet. If I go back and read the passage, then I'll know for certain what the V is and the other V, but usually that's voltage, right? B, 200 volts, C, 250 volts, and D, 275 volts. So let's see. We're going to go over to figure 2 and see if we can just find this information. So I'm going to come right over here to figure 2, just like it tells me. And I am looking for the V sub S, which I've pretty much discovered now is voltage. But see, I've come to figure 2, and then I can see in the key right here, the dashed line is the V sub S that I'm looking for, or the voltage, right? And this is the axis that I'm going to pay attention to for voltage. And it's asking me, what is the maximum? So what is the highest value that the dotted line reaches? Right, so if I follow the dotted line, it's right here. And I'm paying attention to this axis because this is the voltage. I'm not paying attention to the current. That's not what they asked me about. So I'm not looking at the solid line or this axis. I'm looking at the dashed line and this axis. And I can see it's right here, which seems to be lining up with 250 volts. And so the best answer for this is going to be C. Okay. So hopefully you got that one correct for Monday, our ACT question of the day inside of our ACE the ACT Facebook group, which is 100% free. And we have a daily question every weekday except for Friday, because Friday is the day that I go over the questions, and so the week and on the weekends you don't get one. But Monday through Thursday, there is a question that's available for you to work on. You can test yourself, try to answer the question within the appropriate pacing guidelines, and then on Friday you can find out if you got it right. So let's move on to number 22. It says a period is the time required for a wave to complete one full cycle based on figure 3, right? So once again, they are directing you to a particular chart, not to a paragraph, but based on figure 3, the period for V sub L was which one of these? 5 milliseconds, 10 milliseconds, 20 milliseconds, or 40 milliseconds. So you want to refer to the figure and come up with the correct answer. So here I'm going to figure 3. I see my chart. It says the period for V sub L. What is V sub L? That's this kind of thicker dashed line here. Okay, and period is time period. See, the answer choices are in milliseconds. So that means we are looking at this axis, this horizontal axis, and also referring to this thicker dashed line. Okay. It says, what are we looking for again? One more time. A period is the time required for a wave to complete one full cycle. Based on figure 3, the period to complete one full cycle, that means you're starting at a point and you go through whatever, how many highs and lows you need to go through and then get back to your starting point. How long does it take to go one period from starting point back around to the beginning of the cycle? That's what it's saying. So here, time 0 is where we are. How long does it take in time for us to get back level with this point? Well, we haven't gotten back level yet. Dipping, now we're approaching, and here we are finally back level with the starting point. And it took us the entire span of this chart, which is 20 milliseconds. And so this one is H. Okay, good job, guys. If you got that right, we are going to move right along to the next 2 questions for Wednesday and Thursday. So let me get those pulled up on screen. Okay, so moving on to question 23, which is our Wednesday or our past Wednesday question of the day. The good thing about it, guys, is this entire set uses the same charts and the same passage. So we didn't have to change anything. All of the information is still here, which is great. So number 23 says, according to figure 2 and 3, okay, so there's your direction on where you need to go. Which voltage varied the least during the 20 millisecond interval? So this time you need to look at both figures, both of the charts, and you have to direct your attention to these different voltages here, V sub S, V sub R, V sub L, or V sub C, and we're going to see which one varied the least. And so that means you have to know what varied means. Like you need to know that it's going to have little change. Which one was more consistent if it says it varied the least? So you got to be able to interpret the question. So let's take a look at V sub S in figure 2. It's the thicker dashed line. And I don't even need to pay attention to this I right here because it's not part of my problem. So I don't even need to focus on it at all. So I'm looking at this dash line and look at how that voltage is changing over this time period. So it started out at negative 200, and it goes all the way up to 250, and then it goes all the way back down to negative 200 in 20 seconds. Okay, so that's V sub S. Let's look at V sub R, which is the solid one. Okay, so it's going from 0 to like 150, looks like, down to negative 150 and back to 0. So already that one is less varied than V sub S, because it's like that amplitude, that distance that it's traveling from its lowest point to its highest point is not as far. Like this one is going from negative 200 all the way to 250. This one is going from its lowest is negative 150, looks like, to 150. So we can go ahead and eliminate that one. It can't possibly be the least varied because V sub R is already less varied than it. Okay, let's keep going. V sub L here is the thicker dashed one, kind of hovering here in the middle. Looks like it starts at 50, goes down to negative 50, and comes back up to 50. So that's already less varied than V sub R. So I'm going to go ahead and eliminate that one as soon as I get my pencil back. Okay. And now we just need to determine if V sub C is any less varied. So let's look at this one. It has a thin dotted line following it. And that one looks like almost as varied as the first one. So it's going from negative 250 to 250 and back. So that's varying a lot. So we're going to eliminate it. And the least varied voltage out of those two figures over this time period is C. Okay. So you can see, guys, I hope you are, understanding from doing these practice problems that is not quite as sciencey as you may think, right? You didn't have to know any formulas regarding voltage or current, resistance, and all those things like this. There's a paragraph here, and they have this power supply, and they're talking about resistance and current and voltage and amps and all of that. And I'm sure you learned that in one of your high school science courses, and there's formulas and things. But on this test, it's not really asking you to do the science computations or to even know the science theory. You're really just looking at the data, looking at the lab reports and analyzing it and drawing the correct conclusion. Okay, so if you are aware of that going in, if you know that's what you're doing, then you'll be better prepared, and you can, study and practice that skill and build that skill in that area. And then you've got over half of the science test down just from that alone. Okay. And because this test goes so quick, right? 40 questions, 35 minutes, like, since it's so quick, you need to know it going in that this is what you're going to be expected to do, and this is how you do it, okay? And guys, before we do this last question, I just want you to know that these are the things that we train on weekly inside the group. Every Wednesday morning at 8 a.m. we have conversations about the ACT, about tips and strategies, motivation, even current events. And we have one coming up this Wednesday. So you want to make sure you're there where you can get some more tips and strategies in addition to just problems and how to solve these questions and get solutions, but also tips and strategies. So you want to make sure you're there. It's all free. And if you ever feel like, hey, this free stuff is great, but I really need some more assistance, to help me kind of get it all together and get a solid plan of study and what should I be working on every day, then guys, just click the link that I have below to book in for a time to schedule out and build a complete strategy plan, game plan for you to ace your ACT. Okay, guys, I know there's a test coming up in June. I'd love to help you reach that score that you desire to have, to get into the school that you want to go to, or to qualify for those scholarships that are so limited. So if you need that assistance, just click that link and you'll be able to schedule a time on my calendar and I can help you accomplish your ACT goal. Okay, so let's take a look at number 24. It's our last one from this week. It says, polarity refers to whether a voltage is positive or negative. A voltage of 0 volts has no polarity and can be ignored. Based on figures 2 and 3, which two voltages were always opposite in polarity? Okay, I'm going to read that one more time, guys. Polarity refers to whether a voltage is positive or negative. A voltage of 0 has no polarity and can be ignored. Based on figures 2 and 3, which two voltages were always opposite in polarity? So again, they are telling you where to go in the chart. Out of all 4 of these questions, I have not once read the paragraph at all. And now I'm still not. I'm going to go to figure 2 and figure 3 and use my answer choices and see which one is actually, true to the situation they described in the question. So I'm just going to go through it. Like answer choice F is asking us about V sub R and V sub L. Were they always opposite in polarity? Let's see. V sub R is solid. V sub L is the thicker dashed. So V sub R, solid, V sub L, thicker. Well, 0 is no polarity, and here is positive. That's not opposite, but if I keep going, here's another point right here. They're both exactly the same at that point. They're crossing. So that's not opposite polarity, so it can't be F. Okay. Now I'm going to answer choice G. I am comparing V sub R and V sub S, and those are in 2 different figures, so just make sure you're careful there. V sub R is solid, V sub S is over here, the dashed one that I've already kind of highlighted. So at time 0, V sub R is 0, right? This is the one I'm looking at, is 0, and this one is not 0, but it doesn't matter because 0 is no polarity and we need them to be opposite, and you can't be opposite if this one is negative. Negative and no polarity are not opposites, okay? But we can choose some more points if we want to make sense. Let's take a look at, let's say at time 8. So at time 8, V sub S looks like positive, and at time 8, V sub R is positive. So they're both positive, they're not opposite. Sorry about that, guys. I got a notification and it distracted me. But yeah, so I knew it from the beginning, but I just wanted to drive the point home. At the beginning, I knew this wasn't going to work because at time 0, V sub R was 0, and at time 0, V sub S was negative. And negative and no polarity are not opposites. So it was already wrong. And if I was taking the test, I would have eliminated answer choice G right then and there. But I wanted to make sure no one was confused by just the fact that one was 0 and one was negative. So I went and picked another point that I just chose. I chose time point at 8 milliseconds, and I can see that this one is positive. And I could see that this one is also positive. And that is why I said, okay, well, now 2 positives are definitely not opposite, and I'm ruling it out just for the explanation of it. Okay. All right, let's look at answer choice H. We have V sub L and V sub C that we are comparing. And they're both in figure 3. V sub L is this one. And then the V sub C is this one. So are they always opposite? Let's see. Yellow, positive, black, negative. Okay, good. And we want to make sure that they always do that. Oh, it's looking good so far. Look, everywhere it goes, it looks like it's flip-flopping, except for here's 2 points where they're both 0, right? So that's no polarity. That's going to be our answer, H, because they're staying opposite each other everywhere except for when they are both no polarity. And at that point, there's no polarity. So what can you do? And if you're not convinced, let's take a look at J. We'll take a look at J to make sure you're convinced that H is the right answer. Here we're comparing V sub L and V sub S. V sub L was the yellow one. V sub S is over here. So I got 2 different figures. So I'm going to pick a point in time so you'll know. At time 0, this one is negative, right? At time 0, this one is positive. That's good. Let's keep going. Let's go to time, where do we go? Let's go to time 10. So I'm just proving this wrong to you now. Time 10, this one is positive here. And then time 10 is positive as well. Okay, so I want to clear this out because I think I just said that that was positive here and that's negative. So I'm going to clear out all of the annotations just because I want you guys to get a clear picture. The last thing I want to do is have my explanation be confusing. That's not what we're doing here. It is to benefit you, not to make you more confused. So let me get my pen back again. What I'm doing at this point is I'm showing you why J is not the answer. We've discovered that H is the answer. We're just proving why J is not to make sure it is extra clear. So give me a second. For H, we are comparing V sub L, which is this one, to V sub S, which is this one. Okay, and so to make this very, very clear, I'm going to section it off so you can see where each one is positive and where it's negative and that thing. So here, I would say that's a 3, but from 0 to 3, this one is negative. And from 3 to looks like 13, this one is positive. And from 13 all the way on for the rest of it, this is negative. So from 13 to 20. Okay, so I hope that's clear. You can see where the hump is above the 0 and where it's below the 0. That's how you know positive and negative. I'm going to do the same thing over here with V sub L. So we go from 0 to 5 is positive. So that's proof right there that they're not always opposite, because from 0 to 3, they were opposite each other. But from 3 to 5, they're both positive. So that's not always opposite if they're both positive in that instance. And I can show you some more occurrences, but I think that proved it clearly. And so over here you can see from 5 to 15 is negative, and then from 15 on is positive. So yes, the answer is H, because J is not always opposite. It's opposite sometimes, but not always. Okay, guys, so sorry about that kind of flub up just a second ago, but I wanted to go back over it again because I wanted it to be crystal clear why the answer was H. Thank you guys again so much for being here. Come back Wednesday, come back every Friday for more Free View Friday ACT question solutions from official released ACT tests from the past. And if you need help, The link is in the description box for you to book in a time for me to help you build out a complete game plan to ace the ACT. Until next time, guys, have a great one.